All right, let's get started. It's been a few weeks. Oop, not muted there. There we go. That's better. It's been a few weeks since we've been streaming, and time to get back into that habit again. Um, I have some work to do on Jakarta. We want to finish this migration for GWT. I got a short list over here of other stuff I'm going to do too. Ideally, we got some other patches for GWT itself that need to get cranked out, reviewed mostly. I have two patches of my own that I need to respond to some feedback, either fix some things or reply why they're just fine the way they are. And then if we get the chance, there is some webhook cleanup we need to do for GWT to get better, faster deployments, and maybe look at a Jackal Maven plugin memory leak. So, welcome back. Let's get some work done. So the Jakarta project, where we left it, I had some notes here that we need to make sure to work our way through. Some of these, I believe, are finished, but not all are. The main one that remains is the, let's see here, this source is missing. I think this is actually finished. The request factory server, this is the main one. And then we need to test that by making a request factory project. And make sure the server is not using any JavaX servlet at all. Make sure that it's using a modern version of Jetty or Tomcat, and make sure that we get the right copy there. So let's see here. We are probably not going to address this since there's been no progress made there at all. Merge that. Yep, that's a separate thing. Land unrelated changes. Yep, that's a separate thing. So really, this is the bulk of the work remaining. And unfortunately, the way that this comes together to finish request factory packaging is that there is a Java file in the request factory code itself that is the tool that packages request factory. So if you're not familiar with how GWT itself compiles, let's make this a little smaller so it's easier to read. Ignore my Java testing there to confirm how objects compare back and forth. Anyway, we have really only a couple of small class paths, or big class paths, a small number of big class paths when we build GWT. There's the dev class path, which is all of the compiler, dev tools, and most, if not all, of the unit test wiring. And then there's user, and user contains request factory as well as servlet. And then in order to package all that code so we can build jars that go to Maven Central and allow your projects to work, there is some specific code to say, okay, pull out the servlet stuff. And let's see if we can read this real quick, how it does it. It says, grab these dependencies that get put into the same jar. We grab these particular files that are ostensibly in dev, and then a few other files from user, excluding a few things that are probably client-specific. So this is compiler-specific. This is JavaScript runtime specific. I'm a little less sure about what tools means here. It's probably been here for a very... Oh, okay, I'm the one who added it. This is Jakarta change. I probably made some copy of something existing. Let's look at what the previous version was. Annotate previous revision. It's been there in that form since 2008, so it's unlikely we're going to be changing that in any way. I wonder why I changed that. Is it just like an indentation fix? Let's see, here's the servlet one, which is the first one. It says I didn't change that. Additional dependencies, okay, that's just a copy of that thing. And here's the Jakarta specific one. That's weird. It says that I modified this. Oh, but I see it does not think I modified this. Okay, so IntelliJ is just interpreting this differently than Git is interpreting it. Anyway, so all those files, except for these, get from user, get put into the servlet jar. And then request factory has its own way of doing things. So all the request factory code, the servlet itself, for example, as you can see, is in user. If we look for the path here, we'll see that it's all in the user source directory. And then if we look for how request factory, its own build happens, we say, okay, here's all the various jar variants we're going to need. So this is kind of a mess, and I think it's our attempt, it's GWT's attempt, back when it was Googler's building it, to work backward from one giant monolithic source directory to a bunch of standalone, easy-to-use directories. So we have client, client minus source, and client plus source, or does this mean client dash source, so it includes the sources? It's not documented, so nobody knows. We'll have to work backward and figure out exactly what this is supposed to mean. And then maybe someday never do this again. Find a way to rewrite all of this. We have a particular test jar, apparently. And then maybe in here, these will be documented to say what they do. Build a jar file containing a subset of request factory. It's called a request factory jar. We have a particular target, in this case, client. So that's going to be client versus APT versus server. Excuse me for a moment. So I've got a cough, which makes my voice sound a little funny. And hopefully I'm going to be able to stream for a couple hours today, but we'll see how it goes. Checking something. Yeah, okay. Getting back into the routine of how the different monitors and displays work with streaming. Not a fan of Ant. I hate Ant as much as you hate Groovy. I'm not sure that's true. I hate Ant a lot more than I hate Groovy. Well, maybe you hate Ant as much as I hate Groovy. That might be true. Yeah, no, I loathe and despise Ant. And especially when whatever the work is not sufficient to do in Ant, and they call out to Java. So the majority of our work today is not going to be I'm not sure you can hate Ant as much as I hate Groovy, because I have to use Groovy on a near daily basis. If you use Ant on a regular basis, then I'll grant you. So we're calling out to a separate Java file. Java. Oh, I didn't start the captions. Hey, we're in the routine. Captions working now. Well, directions, I suppose, is close to captions. Yeah, looks like it's working. There we go. All right, I'll try to speak clearly, and hopefully the captions will pick things up. Anyway, this class file itself is used to actually do the rest of the build code, because the build code is too complicated, as we'll see, to put into Ant in a straightforward way. And then this one macro def here called request factory jar, let's make it just a little bigger, is going to be called in many different times. We have different targets that basically decompose this to say request factory annotation processors is just going to call that macro with apt source, request factory all, useful for Android testing. Did anybody ever publish from Google how to use this stuff in Android, or is this just one of those, hey, wouldn't it be nice if, that never actually happened? Let's look at the whole commit. Replace request factory validator interface validator with an annotation-based approach. And it was reviewed. Actually, let's look at that one more time and see if there are any files that actually call out. Here's a mobile web app. I'm guessing it does not actually have any Java files in it. Yeah, just some testing. So somebody internally must have done this to say it tests out to work in Android. And it makes sense that it works in Android. But I don't think it ever really got the work it needed to get over the line. Anyway, so a lot of this is just scaffolding to say, here's how we're going to call that one method over and over again with these various variants. Build request factory server source jar, build request factory source class jar. Okay, so the minus does not mean minus, it means dash, and it means I am the source jar for the server, and the plus means I am the class, I am the bytecode and the sources combined into one. Okay, so that's the pattern according to the comments here. And then what else do we have here? We have a test. We run a particular test suite. And we depend on client jars and server jars, and client jars are annotation processor, client, and server jars are server, but not annotation processor. I thought you needed to run the annotation processor in order to get the server to work properly. I'm pretty sure that's true, actually. The deobfuscator has to be built. And I thought there was a shared bit too, but maybe not. Okay, so we have all that. I have recently built the project. So we should have I guess I haven't that recently built it. Let's do a quick distdev while we're waiting for me to finish reading. We'll let that run in the background. And let's look at how Maven is going to deploy, because we want to look at two things. What the eventual zip build is going to be for these jars, so that we can figure out which ones we need to clean up and make Jakarta variants of, and what Maven is going to need to do. So in Maven, we've got the Google stuff that we're ignoring because it's never going to change again. We've got the request factory server, apt, and client. There is no all, and this just declares that it exists, but it doesn't do any of the building. So we need to look at, starting from the top, we will go ahead and maven gwt everything. Maven gwt is defined in one of these other ones, libgwt, I believe. Yep, there it was. I just had to scroll so I could read it. We build a bunch of arguments, like you do in Bash. We customize gwt user a little bit to, I guess, unpack a few things and remove a few things, because we'll have dependencies for them. I'm really glad we have a third build tool for this. Who do we have to thank for this? All right, looks like mostly we can point the finger at Thomas. Sorry. And then we go through each one and deploy. I'm not sure if this includes our request factory stuff. There we go. Request factory is first noted here. 1, 2, 3, 4, 5, 6. There's 6 notes of it here. And then it does a deploy file for client, server, and apt. And it uses the dash source variant and just the name itself. It iterates through. Why does it use I for a variable name? It uses client, server, and apt. So request factory dash client dash server dash apt dot jar, and it adds the dash source. So it never deploys the plus sources. Why do the plus sources exist? Build failed. I probably did something silly. Oh yeah, I'm in the middle of editing this file. That'll do it. Let's go ahead and comment this out. It's not going to be helpful right now. So we don't need the plus source, and we don't need the all for Maven. We might need it for building the full zip that we deploy. And rather than check what the existing one is, I'm going to check what a clean build on the current branch does to get us here. Justin, can you check the StreamBot thing, or whatever we call it? I think it should have piped up and interrupted you at least once in here. I'm not sure it really matters for it to be putting things here, but could be nice. All right. While we're in here, oops, that's the wrong one. Close that out and shift back to, where'd it go? I just completely lost the quit window. I hope it's still building in the background, wherever I put it. I hope it's still building. Just a second, I'm going to find it real quick with all my other windows. Cool. Just somehow got pushed somewhere else. Okay, so our other work we're going to have to do for sure. We know we need to focus on this one today, so that's going to move that. Well, I guess we don't need to move it. We need to make these package info files. That way they have some specific documentation about using the variant, the jar variant that you're going to be interested in. And And let's see. Will this work? Has there been further progress? There's a lot of people saying, hey, can you finish this? And a lot of people saying, what would it cost to help you finish this? But there's not a lot of people who are actually ready to pay anything. All right, we do have somebody right now who's interested in that, and that is fantastic. Let's see here. We've got the various lib itself. Can you go away, please? There we go. The distribution, we'll unzip that in a minute to check it for real, but I think there's a staging here where all the other stuff gets put into. And indeed, we do package the plus source for client and server, but not for apt. That's weird. And we don't package the all. Okay, let's do a quick scan here for dash server plus source. I don't see immediately what's going to copy output into... Oh. So we have this... We don't have anything that deletes all. Oh, this is gross. We don't have anything that deletes all. We do have something that will create it, if you call this, but nothing calls this target. And as a result of nothing calling it, the output never ends up in here. So if I manually call... Okay. This is going to fail, by the way. It fails every other build because Ant is awesome. But it still should copy it into staging, and then we'll see that now all gets copied in. I think that puts it into lib by doing this. Now it should also get copied into here. So lib now has all. It's just doing a quick, hey, are you up to date check right now? And then shortly we'll do the build the distribution itself minus samples, because I did dist-dev, which skips the samples. Here's where it's going to fail, because it's going to find 2 copies of a class, I think. Yep. Because it doesn't properly replace the class directory. So that's irritating. Okay, so we're basically at the point now of saying we know what we need. We just, now we need to go in here and actually check what each of these jars has in them, because I think it's just the server variants. We need a copy of each of these to be dash Jakarta also. And as long as we build those as part of the request factory build, the zip will pick it up. And as long as we deploy them as part of the Maven build, Maven Central will get it. And as long as this jar extractor knows to rename particular classes, which is what this little snippet here was intended to start us on the path of, we will produce the jars to begin with. So I'm going to sort of work backward. Let's take a look at another terminal. We're looking for the request factory servlet. So we're going to unzip this jar. Actually, we probably should unzip each of them to confirm which one has it, but let's just start with this one. Copy its absolute path. So indeed it has it in there. Client, if there's any sanity in the world, it doesn't. Likewise, annotation processor doesn't have it. Okay, so those are the main ones we got to worry about for Maven and for the zip that you can just throw in your class path if you want it. All, of course, will have it because all contains all. And then we want to check real quick. Server source contains both. Client plus source does not contain it. Good. I was worried that it's possible that someone's going to copy it over there because they detected it was a source. All right. That only contains that copy. Good. And then all we've got left is annotation processors. apt source apt plus source. They didn't build one. For some reason, that doesn't exist. Is that another variant that is declared but doesn't exist? No, it isn't even declared. I bet this parses it, though, if you ask for it. Let's take a look. Yep, it just if target ends with. So it can apply to any target. So there's this matrix of annotation processor, all client, server, and plain jar, source, and both. Of these, what's that? 4 times 3, 12. Of those 12 jars, we only actually need 1, 2, 3, 4, 5, 6, 7, 8 of them. 4 of them just are completely unused. But at least the code is super generic and probably works in all cases. We'll find out, I guess. Okay, so now we know what we need there. Let's go to Maven. Maven should be, let's see, it's not this Maven. That's the older build. Here we are. Here's the request factory part. We're going to need to not just client server apt, but server Jakarta, which presumes the existence of request factory dash server dash Jakarta with a source jar. We are going to need a POM for it. We're going to need to declare a POM. If we look at what request factory server has today, there is no dependency on servlet, so pretty much we can just copy this as is. Let's make a new server Jakarta pom.xml. Oops, I meant to copy the contents, not the name of the file. Server Jakarta. Oh, it's got to be called POM template. Did I hit the wrong key to rename this? Now let's move. I just have my muscle memory for renaming. Rename file. There we go. All right, so we're going to rename this to be I don't think we need to do anything else for this. Just plain validation. We still need JSON. We'll need to add that eventually. Let's go ahead and add now. So that should be enough there. Next, we need, again, working backward. So we've got the part that will deploy the POM. We have the POM itself. And now we need the thing that will say which jars we need. So under build server jars, we also need request factory server Jakarta, which doesn't exist yet as a target. It's complaining about that. We'll make it happy soon. Source plus source. All right, and now we need the targets for each of those. We'll put them right here. We'll just go ahead and duplicate this whole section. Okay, so now we have the targets that will call that, but they have not been customized properly yet. And we have the command that when you build the whole deployment, when you build for Maven or you build for a giant zip, we will produce those. And then last, we need server dash Jakarta. Seems like a missed opportunity there. No, Jakarta's of course picked because it's another island or another city in Indonesia, like Java itself. Okay, so that is right, I think. And last, we need to do the actual work of updating this so that it knows how to handle that case. We need to look for where server is already declared as a string. There we go. There's a string server here. And that's it. The only place we actually mentioned is here. So we'll just start with this. And then we need to tell it which classes to use for real. We need to replace the regular classes it has with the Jakarta classes. Now, the annoyance we have with this is that we are producing a request factory server. I'll show you just a second here. We are producing a request factory server and a logging class, which I think are the two main files we need to replace. We'll check that in a moment. If I look for this file, I have a particular file here that's checked in, and then I also have a Jakarta variant you can see from the path here. And this Jakarta variant has had its package automatically rewritten. This work we've already done. We did this a long time ago. Nothing else really has to change, except, of course, the imports to change JavaX servlet to Jakarta servlet. And everything else works the same way. It compiles, it runs. We have only one other class that has to be rewritten, plus this class here. There's a logging request. So we're going to have to rewrite that one too. So my initial inclination was to say, okay, these are already being produced automatically. We don't need to make them ourselves. Here's the source. And then in here, and this is a little more complicated because this is all of the bytecode for everything. We have request factory. What do we have? Server. Here's server. Then the request factory. Oh no, I'm sorry. There's a Jakarta package, which is where the bytecode itself is. Decompiled class file. So we're already producing this, and it's on our class path, as long as we add the bin Jakarta class path instead of the bin class path. But we need to actually copy those. We need to run the extractor with that different class path instead. So what's the easiest way to say, hey, go ahead and grab the Jakarta variant of this instead of the request factory servlet variant? And my inclination was at first to say, find the regular one, which is this one here. You can see its package in the pop-up is request factory server, and replace it with the Jakarta one. But the Jakarta stuff, at least presently, isn't on the same class path right now. Let's look at how this is actually used. We have the class objects. We take the server. Server classes goes in seeds. Seeds is iterated. It uses to build all. Let's see. We make a source only and code and source variant for each seed. We make a test variant, which we must use for running tests, but we sure don't use for deployment. So I guess I missed that axis here, how we run that. Let's double check that. I don't like walking through this space of possibilities and ignoring one of the options. We need the build file for request factory. Right here. Okay, so it explicitly runs these two only. Is that going to produce files that will build in the actual deployment? Will these test files end up here? Is that what this means? That's a little gross. Let's double check this. Maybe there's some special casing in here for the target. No, it says dump it out there, even if it's a test file. We might be able to fix the class path issue just by duplicating this and saying, hey, now you can see that thing over there, but it would need to be on the compile class path. The other option we have is to duplicate the request factory jar extractor, so we have a Jakarta specific variant of it. And that way it just knows what to do because it found those particular classes. This is awful. All right, anybody want to do something else? This is awful. Let's download, just for fun, download another copy of GWT. I probably already have one ready. We have a temp directory here. Ew, what's in it? Jakarta sample app. All right, we want to leave that alone. We might need that for later. Let's just go ahead and unzip whatever copy of GWT I have in my downloads. Most of them, it turns out. 2.10. Let's do 2.10.zip. Oh, I've got 2 copies of 2.10. Let's see what we got. This should have run the tests when it built. But I don't see any test stuff in here, so I wonder if the tests don't necessarily unpack. Or worse, if the tests don't run when continuous integration runs. Or maybe when we built this, we didn't run a full deployment. That's another possibility. What do we got here? 2.8 maybe? Yeah? I don't see tests in here. So it's not just me who did that wrong, if it is indeed wrong. Let's go ahead and kill those real quick. Cool. Okay, so how do we actually produce the test stuff? And then we'll do a distdev after that to make sure that things are sane. So if we say, let's see, is this set here anywhere? They tell you how to disable it, but we don't already disable it. So if I run this once, well, what's going to target this? Test depends on it. Does anything depend on request factory test? It's a terrifying thing to see. No references found. Let's make sure that's true and that IntelliJ just understands ANT as well as we do. Compile tests. Run tests. Good. So just for giggles, unknown target test. Request factory subtarget test. What? Target test calls request factory test, which is up there. Calls request factory target test. We should undo our changes here. Actually, let's leave this here, because then we'll at least get something to build. And then we'll just comment this out real quick. Java returned 1. Unknown target test. Can we get more stack trace than that, please? I'm guessing. Unknown target, test. Right there. Target comes from seeds. Seeds is populated in a static block. Try to get the test classes. If you can find these, we will put them into here. Allows the rebased package to be tested. This is done with a by name lookup since GWT user code is compiled separately from its test. We're at the how did this ever work stage, I think. Or else you're just not allowed to call test. You're not allowed to run tests as just a single project. Oh dear. Let's do some logging here. Something's not rebuilding. Let's see, what do we got to do to rebuild? That's just going to repackage stuff. What was the target for compile everything from the root pom? There's compile tests, which depends on basically everything. So this is probably more than we needed to do. I'm surprised there's no just straight up compile test. But there isn't. I mean, I really shouldn't be surprised, right? The way the rest of this ant build setup is rigged. Why should you just want a sanity check? I'm curious why it's making package info for tests. We don't distribute that. But it probably doesn't cost anything, so that's fine. Oh, there's a specific test RF, which will first compile tests for those, which is basically what we just asked for. And then it will call test on request factory. Okay, so that's pretty nearly what we would have done anyway, what we're in the process of doing. So I don't think I feel too terrible about that. But compiling 3,700 files in one go is apparently not quick. It also doesn't help that we haven't compiled the tests yet today. There we go. And now it's doing dev compile. Now it's doing Java 8 compile, I guess, for our particular JRE emulation stuff. I'm going to go ahead. Oh, there's a build only. Oh, no, it depends on build only. What is build only? Wait. Without distro packaging. They couldn't have called that compile. They called the other one. It doesn't matter. Whatever. Hopefully this is not going to redo stuff compiled Jakarta. Okay, good. So as you can see, scrolling by there, we only have 29 files that are different. Oh, good. And then stuff doesn't work. So hang on, has this... These are the errors that we get when it tries to build each one of these. And it sure has the appearance that this has not worked in a long time. Let's look at a nightly build and download the set of tests it says it ran. Here's the reports of what it ran. I don't think it lists what it ran, at least with our current setup. Let's look for the... Let's see, these are the builds themselves, I think. And then here's the reports for each of them. It doesn't matter at this point what you're doing. CD into temp, unzip, downloads. It's going to be some JUnit reports Java 11 zip. I hope that wasn't a really old copy. No, it wouldn't have been, because it would have told me, hey, do you want file 1 or 2 or 3? That's not an option. Cool. Okay, so we're looking for request factory in here. Sure seems like it ran that. What did it complain about before that it couldn't find? Request factory JRE suite in VM. Request factory JRE suite in VM. So maybe it runs request factory tests as part of user, but not as part of request factory. Yeah, that looks like it's true, because you can see here it's in user. Where should the test stuff go? If we look in the request factory build, here's the particular tests it wants us to run. It runs the suite as a main, apparently. Is that a thing? There's a suite file or a suite entry here and a main entry here. Interesting. But we're getting a class not found. Apparently a custom stack size. You don't see that very often. The test jars. It's not clear to me where the output is going to be, so let's go back and check that main again. Does it actually write an output, or does it just give you an error or an exit? I think it just logs it. I don't think it writes anything anywhere. Look one more time. Java, fail and error, fork, class name. There's no, hey, dump your output to this particular path. It's weird. So I kind of want to go on an adventure back into the past and figure out, in 2014, did this work properly 10 years ago? And at what point did it stop working? Let's just pick one of these at random and make sure that it runs that test. See, these are the factories that are going to be validated. And then the tests it will run are in the suite itself. The way that this works is it says run the suite. The suite is the output of this. So pick one of these. Make sure that it's in this particular file here. Sorry, like this. It ran. So it runs it as part of user and not as part of request factory. That's disturbing. Okay, well, we're already here, I guess. Right? What else are we gonna do? About to add tests, failed to add tests. So this just doesn't work? I think that is, that's going to be sort of a next week problem kind of a thing. Here meaning never. Anybody use Request Factory? I see we got 6 people here, and one of them's Justin who doesn't use it. Okay. If we make two copies of this, two variants of this, one with server and one with Jakarta, and we recompile this file, we copy this file and make another variant of it that will go through and find the particular types we need and change them to be their own Jakarta variants, that will nearly work. Now we just need to, in this build file, say, don't run the usual class, but use a .jakarta variant instead. So let's try making an attribute out of that. I know, Justin, we both worked at a customer who used it for a while. They mistakenly perceived it as, please migrate away from RPC, but never fully migrated away from RPC and just used half request factory and half RPC, and blamed both for their bad code being slow. All right, so let's see. The other attribute is main. Yeah, main. We'll just call it main. Default to there we go. I'm an expert mouse user who can click on things. All right, now we need to replace this with, what is it, at main? And then we're going to change these to say this is just awful. I really hate this the more I look at it. We're going to put the same thing in twice, one for server Jakarta. The server Jakarta will ensure that the zip name is different the second time. How does this actually build the zip? Let's see, it runs this, and that's it. I guess that actually produces a zip file. How does it do it? Oh, okay. It just uses the zip API. Is it safe to assume that this produces manifests and everything? I don't even want to know the answer to this now that I think about it. But this is one of the things you have to look at. Just out of horror. Oh, good. There's a copy of Java emulation in the request factory client jar. That's exactly what we want to see. JSON itself gets unpacked in there. I mean, I guess at this point. Why not? And there is a manifest file. Okay. Was this always this way? That all of JS interop itself is unpacked in there? Because that's silly. We're going to have to go back into temp and unzip our, say, 282. There's a manifest. There's JS interop. Why is JS interop unpacked into the request factory client? Dare I ask what gets unpacked into the server? JS interop. I'm betting there's a deny list, but there's no allow list, and so it just picked up Java emulation and JS interop as prefixes it wasn't expecting. I don't even know, guys. All right, well, the horror continues. Beyond my usage of a white theme for IntelliJ, I'm sorry, my office is well lit, so it doesn't bother me to have a dark theme. Oh, good. We have references that don't resolve. Is that because it's hidden or because the, it doesn't matter. Let's leave quit 282 here, just in case we need it back again later. I could imagine that being a thing. Request factory interface validator, there is no file with that name. There never was. Replace this with an annotation-based approach. I'm so glad that somebody was on top of checking for references and errors in JavaDoc. Oh, and it's in the old app spot too, which Google told us we don't need. There's nothing useful in there that we would want to go back and understand what was going on there. Thanks, Google. Populate the bad types with the current context. Doesn't do anything. Okay, all right. It's fine. Everything is fine. So we're going to try and move this, the jar extractor itself. We're going to junk this section here. It's already commented out, so whatever. We just have to rewrite the request factory servlet, the logging request, and the logging type itself, because logging uses uses JavaX servlet request and logging request as a reference to logging. So logging request has to be moved to its own package. That way it can reference logging in its own package. We've got just an indirect reference there. So it's a total of 3 classes that have got to get rewritten. Logging, logging request, and request factory servlet. Nothing else needs to be moved because nothing else directly references this. I hope. Okay, there's HTML files that reference it, but you don't count. Servlet, the extractor references it. Three things that reference it. All right, let's go and look at how we are actually producing the different copy of user bin Jakarta instead of bin, and move a couple more files into there, because as before, this is built from this directory plus the regular source directory, which is just a couple of things here. And for request factory, it is 3 things, and now it will be 4 things. So we're going to put the request factory jar extractor in the same place that handles request factory servlet. Okay, so we're going to find the reference to request factory servlet in the XML file. Just go ahead and change the filter for that rather than mess around. Oh, good. Tests are definitely what I want to be seeing. User build. Here is all the replacement code. So this is the bulk of the work done so far by Sandra Parsik and myself to rewrite the code we need to be Jakarta specific. And we need the request factory part here to say request factory servlet and logging need to get moved from server to their own place. And now we're also saying the jar extractor, which lives in the server package despite not being useful on the server. Everything is fine. Hash map? Why would I have added a hash map? Okay. Let's alphabetize these. So there's at least some semblance of order, or is there another order here of like dependency relationship? The rest of these are alphabetized, so let's alphabetize these 2. Jar comes before servlet. Logging comes first. Now, for each of these, we do a little bit of replacing. We look for JavaX servlet and replace with, we look for JavaX servlet and we replace with Jakarta servlet. Basically, anywhere they appear. This allows us to rewrite not just imports, but also documentation. And then there is a package line we rewrite, because these are both server, getting rewritten into servlet. And there's also RPC servlet utils, which apparently we depend on from request factory servlet. So this makes it seem to me as though logging is going to incorrectly reference the servlet. Let's look at logging here. Oh, they're in the same package. It won't matter. Never mind. We don't need imports because they're in the same package. Okay, so there's no need to rewrite anything else there. We do need to rewrite the logging request, though, because request factory jar extractor is going to reference logging request. Let's verify that. Shared logging request right here. So we need to rewrite that import to be a Jakarta variant, just like it is here. And that is here. We're going to say find the reference to logging request and replace it with Jakarta variant. And then logging request is already rewritten. And that might be that. Because now we've changed, let's think about this. Now we've changed, we've got a new copy of the extractor. We're going to run it. Oh, it failed. Failed right away. What? I think we have a special thing here that's going to build this path of no servlets. Aha, okay. We're going to go ahead and unexclude this. So we had a custom exclude here to say, I know you technically are going to apply here, but we're not going to check you. What is this? Should we include this? It says it's example code. I mean, my own note says it's example. Is that my note? My note. Annotate previous revision, which is apparently a conflict. Okay, I guess that was my note. The newest one here is this one, annotate previous revision. This is just a merge conflict that I introduced. So I appear to have deliberately said exclude this. Start copying all sources as is to a new directory. Note despite the name, there may be a small bit of servlet-specific stuff in there, mostly for the JUnit runner, which will not be updated at this time. That's true. We should probably think about tweaking that one too. So we'll come back to this later on. I would never check in a to-do and have someone else have to catch me on it in a review. That would be embarrassing. What do we do wrong here? Cannot find simple request processor. So this is the version in Jakarta. Oh, because now we've got all these imports that need to... Okay, that's fine. Everything is fine. We gotta be careful about how we add imports. That way we correctly import the Jakarta variants over the non-Jakarta variants. So this might be this might not be this simple. I think we've solved this problem in at least one other place. So let's lean on previous work we've done here and take a look. For example, do we ever add a new import wildcard? Yeah, check this out. So we say at the very beginning of the file, when we first do our, what does this say here? /**, /** that starts the line. So that means the Java doc for the class itself. Add an extra import, two new lines, and then another **/*. But it's a single other import. So this is a good pattern to look for other places where we've done this. We aren't doing wildcard imports. We're going to have a whole lot of classes that are going to have to get referenced in this way, I think. Let's try to quantify what a whole... Oh, hey, we did a wildcard one here. Okay, maybe we give it a shot. I suspect this is all going to go horribly wrong. So we'll have to manually spot check the generated code. Let's just run this one target. It should be a lot quicker. Okay, so here's our Jakarta variant of the extractor. It left our comment alone and it added right before the end of it a wildcard. The question now is, did it break our list of server jars? So which ones are these actually referencing? And because it's not compiling it, it can't tell us. Let's tell IntelliJ that this is actually a source directory for the duration. Mark as sources. Generated sources? Yeah, generated sources looks good. Wait for it to think about that a little bit longer. Hey, cool. That worked. So that is pointing to the regular server variant. Server variant. Jakarta variant. Aha. Jakarta variant. Jakarta variant. Hey, better lucky than good, right? All right, cool. Okay, so we can back out these other changes and pretend we never saw this file. We still got this one change. We still got one change we're making into this file here. It's okay. 6 people still entertained by this. What is wrong with you people? All right, let's try this. Do we do a full build here? I mean, we're streaming, right? Oh, we're in the wrong. This isn't. I don't know. Whatever. The people whose judgment I'm really questioning are the ones who are watching the VOD later upload on YouTube. You're the ones who've got the real problem. All right. I mean, this wouldn't be so bad in. I mean, okay. I'm about to say something that I can't believe I'm about to say. This wouldn't be so bad in Gradle. Maven, this would be pretty bad. You would have some other external build stuff to say, okay, this is awful. We're going to move the really awful stuff over here because what is wrong with you? You shouldn't be doing this. But really, there's a whole lot of you shouldn't be doing this in here. I mean, there's just layers of old junk in here where let's find out where that mistake is happening, where we're picking up Java emulation stuff and putting it in server jars of all places. I mean, how do you even follow this? Never mind, we couldn't write it in Ant, so we wrote 1,000 lines of extra Java, lightly commented Java. Oh, good, there's a to-do, someone checked in 2011. Interrupted means retry. That seems... Really? I wasn't paying attention. Did it finish? No. So something in here is picking particular packages and classes and excluding other things. Native method defanger. Oh boy. We're rewriting bytecode. It replaces native methods with stub implementations that throw an exception. This allows dangling GWT types to be loaded by the JVM without triggering unsatisfied link error. I mean, we're not rewriting code in here. We're just copying files. We're not even compiling files. We're just copying. We're saying, hey, bytecode over there and Java files over there. Hey, go put them over there in a zip. That's the cool part of this. There's a zip file involved. There's got to be a reason for this. There's got to be a reason. And there's no bytecode getting rewritten. A unit of work to write one class file and source code into the emitter. The emitter, capital E, is a zip file. It's a thing that writes a zip file. Emit one resource for each resource. Okay, so why do we do it in a loop on other thread? What? It's an exec service. A single-threaded exec service. So why are we doing it in the... You know, it doesn't matter. So there's emit one resource, emit one type. They are just callables, which is how we pass them off to the executor service to begin with. All right, what are we doing here? Process one type, as distinct from emit one type. We run this in process type. What do we do here? Processing a type, possibly returning a rebase type. Oh, so it's actually moving things. Oh, and here's the here's the package thing I was looking for. If it's not in Java or JavaX or Common Google JSON, if it is in one of those, we leave it alone. I mean, this isn't even wrong. It's missing another argument. This is just a brand new file. Okay. Here's a verbose flag. Let's turn that on, see what happens. Let's make sure it worked. It failed because of... Couldn't find the jar extractor. Oh, because we didn't add the right class path. Okay, that's on me for sure. Gross, but whatever. 3 minutes, 27 seconds, and this time we'll get some log output too when we start running the extractor. Okay. You can probably put this on the other line, just a little bit of other cleanup as long as we're here. Maybe correct this comment, because wrong comments irritate me. Source includes Java files, plus source includes Java and class files. Is that strictly accurate, or are there other resources we copy in there too? Let's make sure we've got a short log here to review later, because I want to see what all this verbose junk is about. All right, it's going to say source type. What does source type even mean here? To do. Right. We already talked about that. Why is there a singly threaded executor service doing these when we're running it from one thread, and then we just have a second thread wait for the first thread? Wasn't there like a thread count thing in here somewhere? I saw the number 4. Max threads 4. Number of threads, fixed thread pool for X, and then writer service is a separate one. What is X doing? X is, we're doing processing types here, and then we return a future. No, we don't even return a future. We submit, we say in process, we've got the type that we returned, and as long as we wait on all the in process futures. Okay, so that's at least spread out across threads. I really want to know how long this actually takes, that we needed 6 threads to get this work done. Because based on this, what I've seen so far, we're talking about hundreds of milliseconds. And we're invoking it up to 12 times. And we're starting a new JVM with new thread pools every time. So we're recreating, what's that, 6 threads, how many times? 12 times? Are we really saving enough by using those threads? Let's look at the original diff. Can you not see Gwt project in here? There it is. You jerks. 404. All right, let's see here. There must be a deleted file in here somewhere. Here's the rearranged files. We don't want rebind. We don't want UI. We do want server. Jar extractor is from whole cloth. Is there a removed file that could have corresponded to this? There is not. What's the package we started with? User, so it's com Google Gwt web bindery. No, it's com Google web bindery. Web bindery request factory Gwt. Okay, so Gwt used to be inside of request factory, and they just removed the Gwt directory, but then added the request factory processing, extracting magic. Something failed. That's not found exception for Jakarta servlet main. This is probably loading. Yeah, okay, so when we loaded the request factory jar extractor, we do not have the Jakarta class in the class path. Okay, that makes sense. We don't have Java X Servlet either, as far as I can tell. Where would we have picked up Java X Servlet for normal development? For more normal builds, for Java X builds? I guess we would have gotten it out of dev. Dirty. So let's look for where a Jakarta jar would have come from. We got one in here somewhere. I can't tell between errors and finds because the find color is the same as the error color. Thanks, guys. Compile Jakarta. Let's go to that one. Here we are, Java C. Here's our path. All right, 3.5 minutes, go. So just to double check here, the pop-up says we moved from com Google GWT request factory to com Google, oh, I see, the web bindery is new. It used to all live inside of GWT. That's weird how the tree is displaying it. I moved to com Google web bindery. So I think this was an intention, at least the way I read it, an intention of moving to support it in Android. And it just didn't work out that way. Or it did, and only happened inside of Google, and nobody ever else talked about it. So that was the end of that. Okay, target should be one of this. Let's put a quick note here. Feels about right. Still don't know what we're up to here. Let's give an example of what process types can be called on, other than the seed types. I guess it's recursively visiting all the other types and rebasing something. So to return is if type internal name starts with one of these, then we leave it alone. So we don't rebase JSON. And we recursively look at element type if it's an array. If it's not an object and not an array, we leave it alone. We note that we have seen it in a, let's see here, what's it doing? You get it. If it's non-null, you return it and you release the lock. Otherwise, you get its descriptor and you make a type out of it. And you cache it in there. So this is a compute if absent on a concurrent hash map, except with a synchronized block because we don't want to call compute if absent for some reason. Maybe compute if absent didn't exist at the time. Is there another synchronized block in here we're locking against? No, it's just ourselves. We're only guarding against our own interactions here. Type get type is going to cache internally? Yes? No, it creates a new one every time. Okay, do we need to have it be a particular instance? Okay, well, it built and succeeded. Let's see what we got here for some of our logs, for examples of rewrites. What? What is going on here? It says the source type to the class name. Are these like nested types it's moving around? JavaScript exception gets moved to impl. So it used to be com Google GWT core client JavaScript exception, and then it gets moved to client impl JavaScript exception base? No, that's got to be the super type or something. I must be misreading this. Type get class name. Type is the we pass in a source type and a type. And then we log the source type and the type class name. Stack trace. This must be dependencies then? Seeds is going to be printed first along with some seed. So yeah, this is a giant graph. So for example, GWT depends on JS logger, and then later else we'll find JS logger to say what JS logger depends on. So we can build that thing there. Process one type for type, which is the second argument. And when you submit process one type, it is going to do the call, which will say, is it going to recursively call process type? Do this. Not directly. Emit does emit one type, which also does not do that directly. Oh, let's see here. Emit type is going to... There's only one implementation of the interface. Awesome. Read as string. And then you make an input stream from the bytes. Wait, wasn't this just an input stream? This was an input stream. Am I crazy? Are we not just taking a stream, reading it fully into bytes, and then wrapping the bytes in the stream so we can pass it to emitter? Isn't this the kind of junk you write a comment on? Like, hey, this way we cache it all in memory, because garbage collection is awesome and free, and buffers are for losers. Guys, I don't know. What am I even doing here? Wouldn't it be better if I just left this alone? I mean, I really want to know what this Java emul stuff is doing. It doesn't look good. It should not be in the server code. I'm guessing what's happening is that some server type is referencing some client type, and we think, oh, we have to get from here into sorry, my brain just failed me. We have to get from this server type into client code, and the client code then necessarily has to reference this Java emul stuff. And so we're stuck with it. So we could use this graph to work backward and figure out who went crazy first to require that we need this JS utils. The JS utils requires all these things, and then something else up here requires JS utils. Yeah, array helper requires JS utils. Array helper is required by stack trace creator, which is required by let's look at the apparently successfully generated jar. So here's the server Jakarta source, right? Here are our roots, our seeds, where we start. And apparently one of these eventually gets us into, so clients, right? Why is that a seed for server code? I'll bet that's the root of all evil here. Yep, that's the root of all evil, if you will. So why is that a seed? So you take the seeds, you get a target. From the target, you... Well, it doesn't matter. You just pass the seeds to the extractor, and then the extractor pulls them apart. So who populates this with that request batcher? Server classes. So request batcher is apparently a shared class, according to this. And I think that's probably, shall we say, untrue. Is this VM code? Where's the module name? Nope. It is not VM code. So let's look for this in other Java files and see which packages they come in. Okay, so here's a server thing. Oh, it's the extractor. So you're wrong. Javadoc user I think this is bogus. Okay, let's check out the output real quick, and then we'll come back and we'll see if we can remove this as a separate patch, because I'm pretty sure this is nonsense. So, unzip l build libs request factory server Jakarta jar. We got the usual garbage in there. We have all of Jakarta in there. We're going to need to exclude that. Pretty sure that's where we do our exclusions. Servlet utils, servlet itself, logging, the shared logging request. The request factory jar extractor does not package itself into any of these jars, as far as I can tell. Let's do this real quick for fun. What? We just want the file names. No, we don't need xargs. We just want... Okay, so it never packages it itself. In itself. But we don't leave them in the regular jars either. Okay, that's fantastic. I thought we did. Let me grab another project I can look at real quick. Yeah, so here it is in GWT user, so it's clearly packaged here. Did I spell it wrong last time? Yeah, I probably did that. X. Is maybe unzip not accepting my star.jar? Yeah, okay. It doesn't accept wildcards. And it only reads the last one. All right, I'm going to go get some water. I'm going to come back here. I think we'll actually probably start with an actual project next. Let's go ahead and start the build again. And then we'll try an actual Jakarta project to see if this works with Quest Factory. Be right back. Yeah, the desktop movement is the point. Seeing the blur. So just trying for a different idea of we played this like a year ago. I set this up. Say, okay, something's happening back here. It wasn't actually me moving the mouse, but it was just the logs scrolling through. I need to finish the rest of it so that we've got the header on the top, rendered by GWT, rendered by Domino. Oh no! It was I took it right out of BRB as soon as I came back. All right, that's pretty good. Let's see what we got. That's much better. Okay, so the important part here about processing more types is this future thing. If you submit to the future, if you submit a future to say process this type, it's going to visit all of its fields, its superclass, its methods, probably annotations, and visit those also, and continue the recursive process. There is some recursive process by which this will cause process type to be called. Process one type will cause process type to be called. So if you return early, you say leave it alone, don't touch it. So by adding Jakarta in here, it keeps our scope much narrower. And we could eventually block, for example, Java emul or JS interop. In fact, we almost certainly should say don't copy JS interop as a separate patch. And then we should also figure out why it's descending into client code anyway, because mixing those class paths is gross. Okay. Let's look at the whole thing real quick and see if anything else jumps out at us as horribly wrong. So a bunch of request factory stuff. A particular Jakarta one. Logging is Jakarta. Logging request is Jakarta. Oops. Now, because a zip file is actually just a whole bunch of streams of individual deflated files followed by a master directory structure, files that can be out of order. We're not going to go through, recursive directories or something. So we'll probably later on in here see, let's see, base64 utils is probably referenced by one of these types here, if not that actual one there. All right, scheduled command got picked up. Oh, right, we're running on 4 different threads. So this work is being done on 4 different threads. So there's going to be some amount of this file was added by that thing over there. The scheduler got referenced by something else a little bit ago. Request batcher. We're pretty sure request batcher is the bug here. We are deliberately mapping all this proto stuff for source maps. I don't know why it's in the server code though. Probably for handling stack trace deobfuscation in request factory. Actually, it says so right there. Look at that. Request factory deobfuscator will then depend on this. So let's look at the deobfuscator real quick. Make sure there's nothing else we got to come back to. Provides access to payload deobfuscation services for JVM for server and JVM-based clients. The obfuscation data is baked into the GWT-based clients by the generator. Then there are references to private types. And then, let's see here, resolve classes with, okay, that's a class splitter you would use in theory to use this. This is just the deobfuscator for the request factory payloads, though. This is not a stack trace deobfuscation tool. Yeah, this is not what I thought it was. So something else is referencing mapping. All right, we can't see their logs right now. Let's come back to it. Okay. This is the server stack trace deobfuscator. So that is now what I was looking for. And this is the one in code server, or core server, which has a reference somewhere from remote logging service util. Is this the one that gets used from request factory? This is the Jakarta one, but yes, this is request factory, web bindery request factory. Okay, cool. Good to know. Let's keep reading. We've already been here. Here's the stuff that we use to read payloads and transform them into beans. Values, anyway. For proxies, we handle them differently because we just grab the proxy out of the database and then we apply the changes, so the changes themselves are serialized instead. Request factory is sort of a CRUD-like thing. GraphQL before GraphQL. I don't know if GraphQL does patch operations when you change things or if it's only a read-only thing. I've only used it lightly before, mostly for reading. But it's like a REST patch and for pulling whole graphs out of the database, potentially. Yeah, that weak mapping shouldn't be there. All right, I think we tighten this up here and we push a build to our Vertispan repo, because we should have Maven jars now for Jakarta. We should test that part, and then we'll download them in a sample project. This protobuf stuff is weird to find in here. Whatever. And then all the client core stuff, which, clearly doesn't belong there. And an extra copy of JSON? All right, this is all protobuf junk. This is Clojure compilers, source map stuff. Back to how do we read values, and then into client junk, back to protobufs, back to source maps. This looks plausible. Let's look at the relative sizes of these files. Here's our Jakarta ones. We did not generate a dash source, so that doesn't look right. We must have missed one there. 1.3 megabytes, 1.3 megabytes. With the just plain one, 968, 968. And then we're missing the source jar. Okay, let's look at that. It's probably right here. No, I must not have called that. I should have called it right here. Yeah, here we go. So I did plus twice. And the convention, such as it is plain minus plus or dash plus, plain dash plus. All right, let's make a sample commit for this. And then we'll go through the whole workflow. There was a to-do we added, right? Hey, there it is. All right, so we need to follow up on that, because we may need to actually add this file. Request factory log handler. This is a client code that implements log handler base that you can wire up. Oh, I see. Because it's client code, it shouldn't have references to Jakarta junk. Yeah, because now we got to reference the variant, the logging request variant. That isn't terrible to move. We just need to point it out. Okay. It's gross how request factory works, because server has to depend on shared, and shared in request factory's case has to. I'm sorry. The client depends on shared, of course. And in RPC or using JSON or something like that, the server also depends on shared. But for request factory, shared depends on the server, because it says, I am a proxy for that type over there. So you end up having to have this sort of 4-part hierarchy where you've got client, and then server, and then the actual interfaces types that exist on the server, and then the rest of the server itself depends on those and somehow implements them using dependency injection or some junk like that. But it makes it a lot harder to describe entities using your default, entity persistence system if your client code has to be dependent on that, and your server has to replace those entities with something else. Anyway, it's just weird. But whatever, we're not here to judge, we're just here to fix it so that we can get the release out. Exclude files to do is this actually an example. I think that we're going to go ahead and fix that before we go any further. Here's the request factory one. I want the user XML instead. We're going to go find that to-do that we just added and un-to-do it. Oops, that's not what I meant to do. Why are you changing that? I want to self-closing this. There we go. Maybe put a new line there. We'll probably put some line breaks in here. And then we're going to go look at that handler, log handler. Who references this? Oh, here's the scary part. Who references this? If this is referenced by other types, then we have to recursively go and check them out too. No, but just logging references it. Okay, so logging is already getting rewritten to Jakarta. So we can just say logging rewrite and request factory log handler rewrite. Okay, that's not so terrible. We'll make them both reference each other. So let's look for where we handle logging, which is right here. And we're going to go ahead and also rewrite the, oops, I got that wrong. The log handler, I need the fully qualified name. Request factory log handler, copy reference, paste it there, stick Jakarta on it. And then we're going to make another one of these stanzas just for the request factory log. We'll do it after shared, I guess. Okay. Now we specify what we move. That's the wrong package. Request factory log handler's name is right there. And then we specify how do we rewrite it. The filter chain, we have to rewrite its package from client to client Jakarta. We have to change the reference to logging from server logging to server Jakarta logging. And then we should not need another import for this. I think that's all we're going to do. So we'll go ahead and remove that. And then in one terminal, we're going to do ant clean dist dev. And then another terminal, we're going to continue, our process of building our commit. So this is simpler now. We don't need those exclusions at all because actually both of those end up getting moved. We are alphabetizing these here and also adding the missing extractor. We are specifying how do we deal with those two entry points into this tree of stuff that's got to change. I mean, really, it's interesting because the extractor tool is very similar to what we're doing by hand here with all this ant junk. It's actually rewriting the bytecode and the sources for some things. It's not rewriting, though. It's visiting. It's just visiting and finding. It's not doing the rewriting. Okay, so it says it's rebasing, but this is a lie. I think that this tool used to do something else. When it says rebase, what it means is, I have no idea. Maybe it used to try and rebase, and it doesn't do that anymore. Okay, so we need the package rewriting here. I guess we never had this to begin with. That's a little weird. Oh, no, this is the wildcard. We're going to add a wildcard import to each one of those. That may not be correct to add it to all of them. It probably won't hurt, though. Let's see, there was no other import existing for other types except for RPC util, so that should be fine. We added the new one for the log handler, client-side log handler. So you get that for free. We are not going to stage that. That's just for satisfying our own curiosity. That's it. Cool. All right. So now let's check that build. We probably got about a minute to go here. We're going to run the Maven command next. I'm going to go BRB for just a minute because I've got a little script I'm going to make sure it does not have any passwords that you can't look at. All right, there's one thing you're not allowed to see, but whatever. The rest is all good. So I've just been, as I've been playing with this, saying, okay, here's the build we're going to go with. It's just a command that is trying to generalize some of the tools to say, let's deploy to quit snapshot. And the default is to take whatever the next release is, add whatever the branch name I'm on right now, which comes from Git. So here's just a little handy command to say, okay, what is the name of the branch we're on? That's a little verbose for what I want to do. Let's look in repo right now. Oh, that's not what I meant. Quit snapshot, right? Be nice way to spell. So dash Jakarta. So we're just going to tell branch that its name is Jakarta instead. And then we're going to say, let's make sure this is finished first. Right, it was over here. It was already finished. 2 minutes, 15 seconds. Build failed. Oh no! Specify at least one source, a file, or a resource collection. Okay, so we screwed up a path. Let's go find that again. User build line 151. Last second changes while you're committing is not what you want to be doing. Okay, copy from here. Oh, I know what I did. Too late now. Well, let's 151. Let's look at the history so we can just go back in time real quick and grab what it should have said. It should have said file set source. I haven't pushed yet, so I'm allowed to rewrite my own commit. I just don't want to lose track of the change. Okay, we're going to look at this deploy script real quick, see how it's supposed to get put together. We saw that we want the branch to be just called Jakarta rather than the full bug ID for right now, just because our branch name is kind of long. That's the intention here, though. If you ran this command, it would give you a branch name, which it would put into the version that it's producing. And then the push command is going to read that version, and it's going to read your other environment variables and go ahead and deploy to it. And then I just go ahead and deploy javadoc to what's presently my own personal server to say, hey, let's check this out and make sure that we're happy with what that looked like. Okay. How long have we been at this? It's just over 2 hours. Not bad. So I want to double check what the regular CI would have done here. Apparently I clicked twice. And it would just go ahead and pipe from none to ignore all the other answers. This is pretty much the same thing we're doing. Cool. Yeah. Let's wait another minute, and then we'll run it. Let's take a look at what else is pending here. We need to look at the sources to make sure they are missing. They have their Java files for new packages. This is noted in the to-do added in libgwit.sh. The to-do is gone, so that implies we finished that. Let's go ahead and check it. Oops, we got a build error here. Logging request. Oh, the shared logging request is wrong. Not this one. This one. Oh, it doesn't actually reference server logging. The log handler is only... Why are you erroring at me? Oh, it moved to the wrong place? Did I not rewrite its package properly? We'll look at that in a minute. The import only points to logging request, not to the server code itself. Okay, so I just screwed this up. And it needs to put it not in Gwt client as the output, but in Gwt client Jakarta. And then change this to shared logging request. School has started, so every cold gets brought home. Okay, let's see if we can check this while it's building. And then we'll try running that command. Let's stage that command real quick. It's going to be GitHub. I've not gotten used to the fact that ZSH auto-complete some stuff for me. Branch is the first argument. So we want branch instead to say Jakarta. And that should go ahead and do the deploy for me. Oh, it is going to do a clean build anyway as part of this thing. Well, all right, fine, whatever. We'll let it do the whole thing. That's a little irritating. It's a good idea. We should always do the dist build just to make sure that we've got a complete thing. Okay, so let's look at what we're building, see what we finished so far, because this is off of a clean build. Do we have a user yet? No, we just have dev, and user is still compiling. Okay, so we can't check that one yet, but we believe that it is possible that that is finished already. New package info file should be added at each newly created package manually, explaining that the sources are generated and not available in the main artifacts, only in the Gwt servlet Jakarta. We probably should also reference from the server packages that hey, there's a Jakarta variant you might mean instead. Go look over there. So we're going to look for this at this generated source path, which is just the generated stuff. Each of these in its real path needs a package info. Still screwed something up. Cannot access request factory log handler in the license. Add source file. Does not contain class request factory log handler. What? It's the Jakarta one that's wrong. It's not this one. Request factory log handler. The package doesn't look right. Didn't we just fix that? Move to this directory, client Jakarta. Oh, but we didn't change. No, we did. Package com Google Gwt web com Google Web binary request factory client to com Google Web binary request factory client Jakarta. But that package didn't match for some reason. Oh, there's an extra Gwt in there? What the heck is that? Why does it say Gwt inside of there? Why is there a Gwt package inside of... Oh, I suppose because they're considering that to be different than client. Okay, fine. Whatever. Package is wrong is the important thing. We got it right up there. We got it wrong here. It's all good. All right, let's be bold and just run it. Next, we're going to make these package infos after we get a working build. I suppose I just had a working build. I could have gone over it real quick, but whatever. We'd rather have a full working build. The new package info file should be added to each created package manually, explaining blah, blah, blah. Okay, so we're going to look at the paths that now exist and go into user. And we'll start with these because they're easy. Client Jakarta. So we're going to make a new package info here. Sorry, I guess I got to say new package first. We're going to do this before the... Yeah, okay. Let's just copy the whole thing, and then we'll make it all format the same. See what my column number is. Oh no, we can't do this. I remember why. Because now we need a client version of this jar and a shared version. Never mind the fact there's no such thing as a shared version. We need one. That's not going to do. Okay, so we're going to go back to excluding this because if we package that one separately, we don't want to package just one file separate. That's a little silly. I'm not totally sure it's going to make sense though with this shared logging thing though. It's remember how we got 12 variants of it and we just added 13, 14, 15? Now we have to add 16, 17, 18, 19, 20, 21. I'm counting that. It seems silly to have to change the client just to use a different server type. Okay, so what should have happened with the old logging stuff in the extractor? See, these are listed as server only, logging and logging request. They don't even seem to be in the shared stuff. Which means they're not on the client stuff. Do we even have a client one? Client classes is URL request transport. They made a 1. So they don't even expect this to work from the client. Okay, so that's why we said that the logging junk is basically example code. All right, we got to go back to excluding this. We got to put that back. That's a pain. We need to go into here. We need to drop this new section entirely where we were dealing with this. We need to drop the reference to the log handler. And we need to exclude the log handler from getting copied into here. And we'll put the comment back. Comment was exclude files. Why are you mad at me? Oh, because I didn't do a quote? So we'll validate that statement to make sure it's accurate. Get in there. What? Oh, right, there's no such thing as a shared jar. What do we call it? Isn't there a shared thing in here? I mean, there are shared types. We just package them in the client and the server separate. Yeah, we call them shared types, shared classes. And it just puts them in both jars. It is so dirty. Okay. So we'll deploy this again after all these tests have finished. We're just about there. Oh, it's odd that this did this so late. Oh, whatever. So we're going to delete that package info that we just created. It's making JavaDoc now. Excellent. Just around the corner from being done. Let's see. Do we have a shared Jakarta now? We do. Let's make a new package in there called Jakarta. Make a new package info. Not going to stage it yet. Likewise, server. Package Jakarta. What? Oh, hey, all right, fine. You're a jerk. What other ones do we have to create? Core server Jakarta. Okay, here's our new version. Path. Confirm. I'm not going to sign it. It's still indexing because it says, hey, there's all these new files that this build thing made, so it must be important for me to revisit every one. Let's see. GWT logging server Jakarta. User server RPC Jakarta. Notice the theme, it's always server, which is why we wanted to avoid the shared and the client thing, but we did the shared thing anyway. Let's see. User RPC Jakarta. Request factory server Jakarta, we already did. Request factory shared Jakarta, we already did. So once this indexing is finished, we can go ahead and create these package info files. Let's take a look on the server, see if they've shown up yet. 2020, September 27th, 2023. Cool, files are showing up. Taking its sweet time here, I'm afraid. This is just generally a slow process. Probably I should make this verbose. Oh, I have a V. Okay, cool. So we should see some kind of logging here. Show that it's coming online. Git javadoc Jakarta. So this is the path that will be updated shortly. I don't think we put a timestamp on the file. So this is where the new description will be once we write each of these package infos. That way there's a little more information. Have we done any meaningful changes here? Server, no, it's logging. Let's look at the request factory. Server Jakarta. Servlet and logging are in there. There we go. It sent the log. It sent the files. Doesn't seem to be here. Here's the original file, the client one, the non-Jakarta one. We will need to decide if we're going to actually handle that logging or not. We may want to back that out. Okay, let's start writing some package info files now because it looks like it's ready. We'll go ahead and add. Do I still have the? I do not. All right. Next is logging server Jakarta. Package info. Add core server Jakarta. Package info. Add. And that's it. So we should have 5 new files now. 1, 2, 3. That's not quite the same as 5. Maybe I ignored them last time. Yeah, here we are. Shared. That's not the right button, right? No? Still no? I'm forgetting what my shortcuts are. All right, so there is the new Jakarta for shared. And I didn't make one in here, so we gotta make one. New package info. Okay, so let's start by copying one of these existing ones as a template and use that to rewrite all of the other ones. Okay, we'll just go ahead and tweak this slightly. Year is 2023. And we'll apply this to each of the other ones. Okay, this is for shared. I'm suspicious we're going to go ahead and remove this. I forget what the chain of dependencies is that gets us here, though. Yeah, I'm pretty sure we don't want this. I think instead what we want to say is we're going to change the javadoc for logging. Oops, that was the wrong wrapper. There we go. Okay. This is irritating that this doesn't exist as provided by log record as JSON object. So what should that be instead? Log record as JSON object. It's right there. It's just private. Here's a public one. I think is what they meant instead. Cannot resolve symbol. Log record as JSON, public static. What's the difference? Oh, I see, because there's an import. And it was just wrong before. I wanted to qualify that import. Like that. Right, nothing calls that. You're just expected to call it yourself if you want to use it. Okay, cool. All right. I don't know why that dot was wrapped to the other line. And then let's get rid of logging request. Let's stop handling that one. So that means shared goes away. One less package info to write. Hey, we already did it. Let's comment it out. And then logging request for shared gets removed. But we still need the rest of it. Let's make sure that's coherent. And then we'll try a sampler too, if so. Let's go ahead and write those other package infos real fast. We're going to delete the shared one. This is the server one. Here's the shared one. Is that better? I feel like that's better. That's a character too long. Oh, it's fine. I guess we're going... What's our max character count up here? 81? It's fine. $81. Good enough. We'll wrap these in code blocks. And then wrap that to the next line. It's nicer. We'll go ahead and put that here. It's the same thing. We don't want to do that for this one, though, I guess. This is RPC, so we just put a period there, because there's no request factor in this one. Same, only different. It may be that we want the logging stuff to be in Jakarta. Let's check that real quick. All right, let's kick a new build. Okay. See what happens. I bet we're going to get a build failure because of something we forgot along the way. We've only commented out, so we can go ahead and restore it if we need to. Let's look at this jar file. We're in the UI rather than download and unpack it. Just a nicer way to see it real quick. We're going to look for, oh boy, we're going to wait for this to open. Wait some more. There we go. We want to see web bindery server to see if that includes logging types. Oh, it didn't even deploy the Jakarta request factory? Did we screw up? No, it's just out of date. Oh, it's come, Google. Hey, we started deploying to org-wit project a year ago, Colin. You may want to pay attention to some of the notes about this. All right, let's look at request factory, web bindery, request factory, server Jakarta. Awesome. We'll peek inside the jar real quick. Which jar version do we have first? JS interop and emulation. All right, it is what it is. We're not fixing everything in one step. Server has a remote logging service utility. I wonder if it should have the Jakarta version of some of these. Let's double check that. It's in Jakarta, sorry. Logging, because logging is here instead of here, because it's specific to this. Let's go double check what that logging type is supposed to do. Oh, and there's a failure, because the service references logging, and so we need the shared. Ugh. Yep, there's a reason we had shared, the logging request in shared. There's a reason we did that. And unfortunately, I did this months ago, so I've kind of forgotten why I did that. This is why this is all just an enormous pain. So let's think about this before we go and dig up. No, actually, let's dig up the thing we were already doing. As much fun as it is to be distracted by something else irritating, let's go one thing. This references some of the. Why does this reference a client type from the server? Please tell me that's just in. No, they whatever. You're all jerks. I hate you all. Because once you reference this, you're down the rabbit hole of other client code. Ah. Fine. Okay, so do we need a Jakarta variant of this, is the question. Looks like no. I thought maybe we did, but I'm happy to see we don't. We do need a Jakarta variant of this, unless we can get rid of red local bit here. Yeah, I don't think we can. We're requiring on the servlet to give us the header, unless we could somehow just reference the header and the servlet and say, give me the header. I don't think anything else calls this. Attributes. Okay, session attributes. Blah, blah, blah. Okay. Okay, the good news is there we don't have to futz with that anymore. Let's go look at this here and make sure this does make sense. That when we're trying to build or bin Jakarta, we should move logging request. I think that does make sense. We should move it, and then we just don't, or we just exclude it. I think we just exclude it from the Jakarta build. Because it's server only, so the client can't use it anyway, because this is how we build our jars. And we don't want to build client variants of request factory, because it's all crazy anyway. So let's let's explicitly exclude logging request and say if you want to do it yourself. That is in user build.xml, I think is this one. Yep. And we're going to say logging request doesn't get included because we're considering an example. And that's just going to be a gotcha when you update. If you happen to use this, you got to build your own. Okay, cool. Let's add that to last commit while it builds. What do we call that? The log handler. All right, what's next? In theory, we have finished this one and this one. Request factory server now has a forked variant. Need to decide about this, merge this, land unrelated changes to clean the PR up. Okay, I think we're done. If this build passes. There is a merge conflict. So we'll go ahead and merge that next as soon as this is done. And I think we're going to start looking at our next tasks to do. I'm going to pause and get some lunch shortly. That is not the right set of changes. That's what I spend most of my time. All right, we got some let's see here. Here's a comment about how to do this. This allows using installed code with the file protocol. If location.host is set cross origin. Interesting. So this is only removing it in certain cases if there is no host. If there's no host, don't set this so that we don't have a possible safety concern. It is, I think it's totally safe. I just want to put some white space. Oh, no. If there is a host, do not set cross origin. We are setting it explicitly in install script direct. Oh no, the build failed. Don't get distracted. Looks like I committed that. This combined with CORS header set by the remote server permits Chrome to be able to use the stack trace. This also fixes stack trace from unhandled rejection, from promises which reject but are not handled. Also corrected some white space in the JS linker files. Let's look at this pull request real quick. Oh, this is old. There is no pull request. So I was thinking that this was a security protection measure. But if host is not set, what does that mean exactly? With this, it's no longer possible to open pages. Okay. Otherwise, I think I'm good with it. I'd prefer that we close this one. Let's see, when was this released? Um, merge made it into what? Commit. Good time. All right, cool. Now let's go back and figure out what I did wrong here. The request vector jar extractor can't find the logging request anymore. We should have excluded it so it would have been available. All right, I think I'm gonna get some lunch. I'll come back later. We'll keep this going. I may just wrap this up if it's just a small change here that I have to revert back to what I previously had before we started all this fun today. And then if I pick back up streaming again, which would only be for an hour and a half, then we'll pick something a little more fun. So thanks for hanging out, getting work done with me, and we'll see you guys next time.